Let's look at solving trigonometric equations where we need to use an inverse to solve. So if I look at this example, it says solve 3 times tangent of x plus 3 equals negative 3 tangent of x minus 4, where x is between 0 and 2 pi. Here they're using x instead of theta. Doesn't really matter what the input is in terms of, the variable. The solving will be the same. So what I want to do here is just kind of assess, what do I have? Well, here I have x inside a tangent and x inside a tangent. So that's good. I'm going to try to isolate tangent on one side. So the first thing I'm going to do is add 3 tangent x to both sides and get 6 tangent x plus 3 equals negative 4. And then I'm going to say tangent of x equals negative 7 just by subtracting that 3 to the other side. Sorry, this should be 6 tangent x equals negative 7. And then I get tangent of x equals negative 7/6. So this is not a unit circle value for tangent that I'm familiar with. So here I'm going to want to use my inverse function. So I'm going to do tan inverse of negative 7/6, okay, equals. And then because they want my answer in radians here, when I pull up my scientific calculator, I'm going to go ahead and switch it into radian mode. I'm going to pull up the function menu to get tan inverse, go back to the main menu, and enter in negative 7/6, and then over and end my parentheses. And I get negative 0.862 radians. I'm just writing radians to kind of remind us that the output for tan inverse is an angle. Now, okay, what's my interval that I need my answers in? Well, 0 is just 0 radians, of course. Don't need to explain that one too much, but 2 pi is about 6.28 radians. So is negative 0.862 radians in this interval? No, it is not. Okay, so it's not, but let's try to see where it is on the unit circle. I know that the tan inverse range is negative pi over 2 to pi over 2. Okay, so it's in there. So where would a negative 0.862 be? Well, let's kind of think about, I said pi over 2. Well, negative pi over 2 is about, say like negative 1.5 radians, a little more than that, but just gives us kind of an idea. Pi over 2 is about 1.5 radians. It just helps us kind of think about where would the angle negative 0.862 radians be? Well, I'd have to start at that positive x-axis and go this way, and then I don't know, it's about on that diagonal. So I'm just going to kind of pick a spot because this is just for kind of illustrative purposes here. Okay, so all I'm drawing here is this is the angle that the output of tan inverse gives. Remember, inverse tangent is a function, and so it can only have one output, and it said this is how it's created, this is how it's made, and this is the only angle I'm allowed to give out. Even though it's not convenient for this problem, it doesn't know what problem we're doing, right? So it says this angle here is negative 0.862, and again, that's approximate. So I say, well, how would I get the angles that I need to solve this equation? Well, I know that my angles need to be between 0 and 2 pi. So the first thing I'm going to do is I go, well, I can see that if I take this negative 0.862 and I add 2 pi to it, okay, then that is going to be starting at the positive x-axis, so still in standard position here, okay, but then going in the positive direction, so I would land between 0 and 2 pi, but because this negative 0.862 radian angle is coterminal to this angle, it's going to have that same tangent value. So this is just saying that this is a solution that I want, but it's actually in the interval that allows me to have, so 0 to 2 pi. So let's figure out what that is. So I'm just going to do answer plus 2 pi, and I get 5.42. Okay, so this is about 5.42 radians. Okay, but I don't want to miss my other solution. So where's my other solution? Well, I know that tangent has a period of pi. So that means every pi, it's going to repeat the same output values. So tangent of x equals negative 7/6. This output value of negative 7/6 is going to repeat every pi. So that means that across from the angle negative 0.862, I have to have another output of negative 7/6 for tangent. So let's draw that. And so that would be this way. Let me use a different color. I'm trying to make it look different a little bit. Okay. That's just going to be directly across from the angle that I just drew. Okay. But then how would I figure out what this angle is here? I say, well, what can I do to that? Let's start at negative 0.862. If I start here and add just pi, that's a half rotation and will land me on that angle there. So I'm just going to take my x, and I guess I do need approximate even up here if we're being like extra annoying about it, which we always are. Negative 0.862 plus pi is going to be our other solution. And that is, let me just change this one. No, I can't. Okay. Negative 0.862 plus pi, 2.28. Okay, 2.28. So my solution set is going to be 2.28 and 5.42. And so those are the angles in radians. I notice that they do satisfy my interval, which is 0 to 2 pi. Let's look at another one. How about solve sine of theta equals negative 4/5, or again, x has to be greater than 0 but less than 2 pi. Let's take a look at our unit circle. Now, negative 4/5 is certainly not an output that I recognize from the unit circle, but it still helps me to kind of picture where this might be occurring. Negative 4/5 is, let's see, negative 0.8, right? So I'm not all the way down at negative 1, which is the maximum minimum, or the most extreme minimum, right? The absolute minimum value I can have for a sine output, but it's pretty close. So where would that be? Like around right there, right? Think about where negative 0.8 would be on the y-axis. So that gives me this angle here and this angle here. Okay. Now, if I have to use sine inverse because I say, well, I don't know what angles those are, I need to use sine inverse. Let's do that. So what does sine inverse do? It says, well, I'm only allowed to spit things out in between negative pi over 2 and pi over 2. And so I say, okay, that's okay, sine inverse, right? It's limited in what it can do, but it's still enough for us of what we need to do. So I'm going to go ahead and pull that in here, make a new line, and do sine inverse of negative 4/5. Okay, negative 0.93, I think is fine. So negative 0.93. All right, so what that is saying is that, what that's saying is that this angle here is negative 0.93. Now, how do I know it's this one that I'm pointing to here in the fourth quadrant and not this other one? Well, I know that outputs of sine inverse have to either be in this quadrant 1 or quadrant 2. And because this is negative, it's pointing to this quadrant 4 when it can't be the one in quadrant 3. Okay, so this angle here is negative 0.93, and we can like give it a name, say theta equals, where this is some angle theta. And then I go, okay, well then how would I like write that? Because we know that, like, let's look at what our interval is. We have to say just the angles that are between 0 and 2 pi. So I have to say, okay, well then, like, how would I name, say, like this angle, right? Like I want to name this angle, but I want to name it between 0 and 2 pi. So what I can do is I know that negative 0.93 is just coterminal with the angles that I'm trying to name. So I'm just going to add 2 pi. And what adding 2 pi is going to do is just take me around, right? I'm going to add 2 pi. And so instead of coming down here, right, what it's going to do is just turn it around, adding 2 pi, and it's just going to give me the angle that I want in standard position from here to here. Okay, so I'm going to get two answers. I'm going to get x equals about negative 0.93 plus 2 pi. So I'll just pull that in here. Oops. So the answer from the previous one plus 2 pi, I get about 5.36 radians. Okay. And then, oops, all kinds of apps. Now I need to figure out what this other angle is. So let's put it in a new color here. So this angle in quadrant 3, how do I know what angle that is? Well, I can just kind of add some pieces up. So if I'm trying to get to that angle from standard position, so I'm starting at the positive x-axis, I have to go through at first a rotation of pi. So let's start writing this. This is at first a rotation of pi. And then what do I need to add? Well, this angle that I found originally using sine inverse, let's just kind of like look at this as a piece of a pie, like a pizza slice, right? It is negative 0.93 because I'm labeling it in standard position and using a direction to show it, right? I'm saying, and I went in the clockwise direction, so it's negative. But the actual size of it, right, in terms of kind of like a chunk or a piece of pizza is 0.93, right? So it's absolute value. And so that is the same size as the angle just across from it in quadrant 3. And so I'm going to take pi, and since I want to add, I don't want to subtract to it, right? I want to add the absolute value of negative 0.93, but of course that's just adding 0.93. So this is the same as pi plus 0.93, because I need to add kind of the size of this in the positive direction, which would take me all the way to the angle that I want. Okay, so this gives me, let's see, go back over, oh, I'm in the wrong app, but I think it'll still work here. So I need pi plus 0.93, 4.07, about 4.07. Okay, great. So this gives me, and this is again radians, and there are two solutions for this between 0 and 2 pi. So I can go ahead and give my solution set 5.36 and 4.07.